our other GAS program PIs. So I think Gilbert and Sangeeta Malhotra are online, and they're going to both give a short presentation about their programs.
Hi,
And then we're going to talk about Roman science collaboration.
All right. Well, hello everyone from afar. I'm glad that I could be here today to give you a very brief overview of this general astrophysics survey that I am really excited Roman is going to do and is going to do starting in cycle 1. So this is a program that I put together with the help of an incredible team of 140 co-investigators that cover an incredibly wide and deep span of expertise. Clearly, I'm not going to talk about all this science in 5 minutes, but to give the broad context of what this program is going to do and why it's so important, M31 and M33 are two nearby spiral galaxies in our local group. M31 is very much a sibling of the Milky Way, but it appears it has had a much more active recent merger history than the Milky Way, while M33 is much less massive and appears to have had a much quieter merger history. And the beautiful thing about these two galaxies is that they are far enough away that we can get the global context, their entire stellar halos, their entire stellar disks, but they are close enough that we can drill down with Hubble resolution and now Roman resolution to really probe the parsec level scales on which stars and dust are interacting and feedback is happening. And so this program is designed to study both the global context of what has been happening in terms of the accretion history of these galaxies, their satellite populations, the most recent merger for M31, how that has impacted the dynamical history of the disks, and also to study the stars and dusty ISM and stellar evolution using this full global context. Disk structure at very high physical resolutions. And it's going to do this with a 4-component survey. So one of the components, it includes broad surveys of the stellar halos and surrounding structures of these galaxies, deep dives into the disk, very deep fields for old main sequence turnoff imaging, and also a time domain component. Each of these different components has its observational strategy tailored towards the scientific goals that we want to achieve with the data. And I'm going to do a very brief overview of 3 of the 4. The one I'm leaving out of this overview is the old main sequence turnoff observations. Those are basically 2 fields, 2 filters, just going very deep to get the ancient star formation history across M33 and into its halo and in the outer reach and the at distances in M31's halo that we cannot get enough stars with Hubble's field of view to do ancient main sequence turnoff. So the wide area halo observations, these are going to be taken in 2 filters. This is one of the areas where cycle 1 was vitally important because this allows us to get 2 epochs to do proper motions and to actually measure the proper motions of and along these giant tidal debris features in M31 stellar halo so that we can finally refine our models and our understanding of the collisions that produce these and what impact they had on the disk, as well as we can also do some disk halo interface proper motions. So these will be bulk proper motions of these features, which will be doable with Roman and a 5-year timescale. It will also be deep. We'll get beautiful spatially resolved star formation history maps to fold into our understanding of what has built up the stellar halo of Andromeda, what the halo of M31-3 and its extended structures look like. And this is going to be a qualitatively new regime and sensitivity to discover faint features in these areas. We also get 7 filter imaging of the disk of M33 and M31, covering the entirety of the H1 disk of both of these galaxies and all 7 filters, going much farther out than FAT or FATTR did with Hubble and HST. And allowing an incredibly large wealth of studies of stars, ISM, you name it. And then finally, the time domain. This is going to have kind of two parts. There's going to be low cadence fields that cover basically the full star forming disk of M31 over the 5 years of the nominal mission to get long period variables to detect, especially dust obscured Miras, which have very long periods, and a high cadence field to demonstrate that it will be possible with Roman to use astroseismology to get distances to individual RGB stars in M31. This is going to open up the ability to do 3D tomography of the disks of M31 and potentially M33 in the future to really understand its structure in great detail, and how the potentially major merger that just happened in M31 has affected the structure of the disk. And with that, I will pass it on to our next speaker.
Thanks, Carrie. Thank you so much, Carrie. That was great.
So I'll be quick about telling you about the GRISM reionization and cosmic evolution guest observing program that was selected. We have a large team, and this is them arranged according to their interests. Let's go on with it. So basically, the basic point is to do GRISM to a depth of 1 e to the minus 17, which is about 38 hours of observing time in the yellow-orange regions that you see there. And if we can get the position angles that we really want, we want to make it a uniformly deep survey, about 1.5 square degrees to that depth, and about 1 square degrees in the outer parts, which is half the depth of that. So why do we want to do it? How does it fit into everything else? We know very well Roman and Euclid are doing wide surveys, but they're not as deep. And this gives the depth versus line flux depth versus area plot. And GRACE comes in where it can patch, bridge the gap between what JWST is doing and what we should be, what the wider surveys are doing. And I think it has some science applications. If you're wondering about the picture, there's Nancy Grace standing just left of Kennedy. Moving on. So what's the science, you might say? One of the major areas of science is cartography at cosmic noon. We want to go wide enough that we can see protoclusters that will end up being clusters. Protoclusters at redshift about 2, that'll end up being clusters, massive clusters at redshift 0. So that means going wide enough, and we'd be able, for brighter and more massive galaxies, we can see the passive galaxies and get their redshifts, and for line emitters, we'll see the emission lines, of course. And people are very excited, the Sleuth team, about doing the spatially resolved star formation rate. So we'll see how the environment of galaxies affects their evolution, addressing some of the fundamental questions there. Going back even earlier, going this deep is absolutely crucial to going down to cosmic dawn. I think Vihang said something about Lyman alpha galaxies. The point there is reionization is not instant, probably not instantaneous. We don't know. And JWST is showing Lyman alpha emitters going up to redshift 13 or so. I haven't read today's Astro pH. It may be more than 13 today. I don't know. Things change fast. And what we hope to get out of that is basically mapping of ionizing bubbles and going continuously from 7.2 to 10-ish is where we think our sensitivity will betray us, as in he won't be going faint enough. But I'm happy to be surprised and wrong about that. So this figure shows some simulations. The white things are bubbles, and this yellow thing is the Roman footprint, which you know right now, and the red things are JWST fields. So basically, we need areas bigger than a typical JWST field. We'll also see active galactic nuclei, both at higher redshifts and lower redshifts. LRDs at low redshifts would be very interesting. Higher luminosity things at high redshifts. You've heard more detailed talk about this from Beiliang and Bennett, I expect, so I won't go into much detail. This shows what the current predictions are and what a deep survey will be able to do in combination with other shallower surveys. So I'll just put up the names of people in the listed areas that we said we would impact: cosmology, kinematic peak lensing, stars and brown dwarfs, and other things. I also have sincere hope that many of you will find interesting stuff that'll help your science out of this. And please feel free to get in touch if you have questions or if you want to talk. Thank you.
Thank you. Thank you, Sangeeta. That was great.
All right, so while Tiffany's bringing up the slides, thank you. Yeah. Who is already a member of the Roman Science Collaboration? Raise your hand. Okay, so like half of the people in the room. So you can all, those of you who aren't, can ask the people who are what it's like and what we're doing. So I mentioned this as an advertisement yesterday. We encourage you all to join, but I thought per some prompting, thanks. Per some prompting that we might spend a little bit of time just talking about what it is and why you should join. I got that question several times yesterday, so that's good. There's interest. What's the goal, first of all? It's just to amplify the science return from the Roman mission and the benefits of the Roman science investigations to the astronomical community. We want the most science out of Roman we can possibly get, and this is a survey mission, so that it's best done by all of us getting together and figuring out how to use the data in the most optimal way. So specifically, spark new collaborations, draw on the creative talents of a broad community. You might be expert in cosmology, but not realize that your survey is also great for near-Earth asteroids or brown dwarfs. And by having conversations in the Roman Science Collaboration, you can make those connections early on. The Roman Science Collaboration is completely community-led. There's no funding for it. It's all just all of us making it what we want it to be. There are really good pros for doing that. When it comes time to politic on behalf of Roman, we can do that without having to be associated with any particular organization, which is really nice and has benefited us greatly when Roman was threatened to be canceled. The membership benefits I highlighted yesterday, I'm not going to go through these, but you can see them in gory detail. What I really want to do is talk about what do you get? What mechanically is the Roman Science Collaboration? It's a series of communication tools, including a big old Slack space called the Roman Space Telescope Slack. In principle, anybody can join that Slack, but we have a bunch of private channels for the Roman Science Collaboration members where a lot of conversation happens. There's mailing lists, very low volume. There's a wiki where we're trying to get all of you to contribute more content there, including lists of simulation packages, data reduction pipelines, all kinds of fun stuff. A calendar, GitHub for sharing interesting code bits and whatnot. We break the collaboration down into 6 science groups that you can see listed there. Those science groups are what meets regularly, and then the Roman Science Collaboration has maybe once a quarter, or maybe twice a year, all hands meetings. And we're looking forward to, I think, in the future, thinking about in-person meetings as well. Events you see up there, often associated with AAS or some other interesting conference we can get together. And the idea is, in the long run, we'll have a list of Roman projects, and the Roman Science Collaboration can throw its weight behind advertising your projects when they come out as publications through press releases and whatnot, as sort of an official Roman Science Collaboration publication. Okay, that's all I want to say. I'm going to leave this. Okay, so here's the QR code. If anybody wants it now, you can grab it. I'll leave it up here later. This is just on our wiki. You can see we have all kinds of interesting content there. It's actually quite an old one. We have a lot more content than that now. And here's the Slack. You can see all the channels. And then I'll just leave this up here as things you can percolate on. In a Roman Science Collaboration meeting, we brainstormed about what people would want out of the Roman Science Collaboration. This was over a year ago, and this was their list. So I thought I'd throw it up there for answering some of those questions. What can you get out of it? And I'm going to take questions now because this is discussion session. I'm happy to answer any questions you have about the RSC, or comments for those who are already in it. You don't have to clap. It's a discussion. There's one way back there.
Yeah, thanks, Jessica. I'm curious if there's any coordination with like the Rubin science collaborations, since there's probably a lot of overlapping people and membership between the two.
Yeah, we've been contemplating whether we should spin up MOUs between the RSC, the Roman Science Collaboration, and the Rubin Science Collaboration, or Euclid, or whatnot. That's still in the works, and we're trying to figure out exactly what that would look like. So I will say there's lots of people overlap. Formal conversations back and forth are still in the early phases. But if you think there's real value to that, we should talk more about how to structure that. Like a joint conference or something might be an interesting idea.
Thanks. So, do you have a rough idea about like how many Roman the proposal teams were actually working through this like a science collaboration? Do you have any sense about it?
Yeah, good catch. See this middle bullet, discuss ideas for general astrophysics survey program. This was what was proposed a year ago and actually happened. So the RSC comes and goes in energy, in waves. Right before a proposal call is due, we had lots of meetings. I would guess about half of the observing proposals came out of RSC discussions, at least, if not more, actually. So yeah, it was extremely fruitful during that time period. And those proposals, it was pretty successful. Those proposals that were involved in the RSC, those people had access to experts about Roman and the different ways it could operate and observe. And so as a result, we think their proposals were quite strong for that reason.
I think Carrie's was one of those that worked really well. There was a meeting here in Pasadena, and that a lot of people came to that. I think that was really useful.
Yeah.
That's the one that I attended, and no. I just want to say that everyone else who didn't raise their hand should join. If the bar is low, it's not that hard. You are not going to get overwhelmed and inundated with messages and all kinds of things all the time. I joined the Active Galaxies one. It's great. You get to work with people that you can't normally work with, or you haven't normally worked with in the past. And it's a fantastic way. I mean, Roman data will come fast and furious. This is the way to keep up with it, get plugged into different kinds of groups and different ideas, and really stay on top of what's happening. And also, as Jess said, talk to people who are working on the pipelines of the project, because they will be there too, and it'll help you a lot to sort of see what's happening with the data as they're coming out.
And I'll say it's an extremely efficient means of feedback. So as you get your hands on Roman data, or you're submitting proposals, or you're writing budgets, or whatever it might be, you want to advocate for the next generation of Roman surveys. It's bring these up at the RSC, they percolate up to the working group chairs, to the co-spokespersons, and then we can bring it to the project level quite efficiently. Good. Any other thoughts or feedback from other folks who are on the RSC that they wanted to share? Okay, great.
Thank you so much, Jess. And if you have any other questions, hold on a second. If you have any questions or comments, for today and tomorrow, we're still here. And people that are running these and on these, please reach out to us while we're still here through the middle of the day tomorrow.